Hey there, awesome physics students. I want to talk about some of the various forces that we're going to use in our analysis and how they work. So the first one we want to talk about is weight. And the main thing to know about weight is that it's gravity on Earth. It's Earth attracting mass, and all mass attracts other mass. And it's just the attraction force from the Earth on all the objects that are on the surface of the Earth. And so the important thing to note about gravity right now is that it's proportional to the mass of the object. So a larger mass will feel a larger force of gravity attracting it to the Earth. Okay? And this is, of course, a long-range force. And one of the other key components to know about gravity is that, let's say we have gravity acting on a ball here. If we move the ball closer to the surface of the Earth or farther from the surface of the Earth, it doesn't matter if we move it to a different location. It's going to feel the same force, attractive force, to the center of the Earth. And so in that case, it's constant. Okay. Another very useful force that we want to talk about here is springs, a spring force. And so imagine we have a spring and we attach it to a wall, and then we attach it to an object. And imagine I pull on that object this way. The spring does not like to be stretched, and so it's going to exert a force this way. That's going to be a pull or a push. In this case, it's a pulling force because it wants to go back to its original length. And likewise, if I take the spring and I push it this way to compress that spring. The spring doesn't want to be shorter. It wants to be in its equilibrium length. And so in this case, it's going to push back. So it can be a pull or a push. And this is often called a restoring force because it wants to restore the position of the spring back to its natural or equilibrium length. The last force we want to talk about today is tension. Tension is going to be if you have a rope, for example, and you pull on the rope, that's the force that the rope puts on other objects is a tension force. And so it's going to be a pull only. You can't push rope, as they say. And the reason we can use springs as a way to understand what's happening inside ropes, okay? The rope is made up of molecules, and those molecules are attracted to each other. And those molecules want to be just the right distance from each other. So if they get too close, they start to push each other away. And if they get too far apart, they start to attract each other again. Well, that's exactly like what we've talked about with springs here. So you can imagine inside the rope, there's molecules, and they're connected with springs. And if you stretch this too much then those springs will pull back. So it's a pull only. And the other main characteristic to know about tension is that it's going to be parallel to the rope. So when you pull on the rope, if I put a force on the rope this way, that pulling force is always going to be parallel to the rope completely, meaning no part of the tension force will ever be perpendicular to the rope. So if you know the direction the rope points, you know the direction that the tension force points. All right?